My dear participants, today I am going to continue on dplyr, and we were having the pipe operator. The real power of pipe operator arises in combining multiple verbs: flights, filter, destination is equal to IAH, and then we are using the pipe. First we are using pipe here. So first with data flights, we are using the pipe filter, destination is equal to IAH, and then we are using another pipe mutate, speed is equal to distance upon air time into 60. Then we are using another pipe select, year to date, departure time, carrier, flight, speed, and then we are arranging them in terms of speed. So it is being arranged in terms of speed. See, it is in decreasing order of speed. So this is the, then group by. Use group by to divide your data set into groups meaningful for your analysis. Flights, group by month. So it is, and then summarize. The most important grouped operation is a summary, which, if being used to calculate a single summary statistics, reduces the data frame to have a single row for each group. So here it is flights, then we are using the pipe group by month, then summarize. Average delay is equal to mean delay. So it is giving the mean of each month. So here we have not used na.rm is equal to true, and that's why we are getting NAs. So handle NAs. In handling NAs, we have to write mean, departure, delay, na.rm is equal to true, and then it will give the result. Flights, group by month, summarized, delay, mean, and then n number of flights also. So these are the number of flights. One thing, it is delay as well as number of flights we are getting. Grouping by multiple variable. You can create groups using more than one variable. For example, we could make a group for each date. Daily is equal to flights, and then we are using the pipe. Daily is new object has been created. Flights group by year, month, day. So here it is group by year, month, and day. So it is daily. Ungrouping. You might also want to remove grouping from the data features without using summarize. You can do this by using the ungroup. Daily. Here we have made grouping, daily object. It is group by, and then we want to make ungroup. So daily, and we are using the pipe ungroup. So it reaches through the actual number of 3,36,776 by 22. So it is ungroup. Let us see what happens when you summarize an ungrouped data frame. Here, daily, then ungroup, and then summarize. So this is the result. Average daily flights is this one. If it is ungrouped, it is giving a trip bill by 1/2. So without ungrouping, it gives the single result. Dot by dplyr 1.1.0 includes a new experimental syntax for per operation grouping. The dot by argument group by group underscore by ungroup are going away, but you can now also use the dot by argument to group within a single operation. So here this is flights summarize, delay is equal to mean, n is equal to n, by dot by is equal to month. So it will give the month wise summary. Group by multiple variable. So here dot by has two arguments. We are grouping by origin as well as destination and same summary. A case study aggregate and sample size. Whenever you do an aggregation, it is always a good idea to include a count n. That way you can ensure that you are not drawing conclusions based on very small amount of data. We will demonstrate this with some baseball data from the Lehman package. Specifically, we will compare what proportion of times a player gets a hit H versus the number of times they try to put the ball in a play AB. Batters, Lehman batting. Batters, Lehman batting. So Lehman is a package and batting is an object. So we are selecting from Lehman package the object batting, then group by player ID, summarize performance is equal to sum H hit, H stands for hit, na.rm is equal to true, by sum AB na.rm. AB is what? AB is versus the number of times they try to put ball in play. So this is the N and this is the summary. When we plot the skill of the batter measured by the batting average against the number of opportunities to hit the ball measured by times at bat N, we see two patterns. The variation in the performance is larger among the players with fewer at bats. The shape of this plot is very characteristic. Whenever you plot, the variation decreases as sample size increases. That is a positive correlation between skill performance and opportunities to hit the ball N, because teams want to give the best batters the most opportunity to hit the ball. So here batters filter N greater than 100 and then ggplot AES x is equal to N, y is equal to performance plus GOM point alpha is equal to 1 by 10, GOM smooth SC is equal to false, and we are getting this. From the data set processing. Yes. So this is the performance versus number of hits. Batters, and then we are arranging decreasing performance. So this is all about dplyr's section, but I would like to introduce you today about, see, oh, we have to go into view, then pans, and here I have to keep right here. So I have to keep this window, console window, at right upper corner. So we have made this. Now see, I would like to talk about vignettes require dplyr. Vignettes are the articles written by the package developers themselves, and actually those vignettes are in the form of article attached with the help file. So if you want to learn a new package and its implementations, it is best that you should start with the vignette. So I am going to write help vignette available with the dplyr package. There are many vignettes available with the packages. So pack is equal to dplyr. So here, see, these are the description, these are the vignettes, and in this vignette we have many vignettes: dplyr base, dplyr versus base. So what are the dplyr commands and what are the parallel base commands? See, this vignette compares dplyr functions to their base R equivalents. This helps most familiar with base R understand better why dplyr does not show dplyr users how you might express the same ideas in the base R code. So here, these are the functions, some list of the functions like arrange in dplyr, arrange data frame and then according to the numeric object. Here in base, we have to write this whole df, data frame, then order x and then drop is equal to false. Similarly, distinct, df data frame and then object. So it will return distinct object. But here, df and then no duplicate and then drop is equal to false, then unique and unique. So these are the base parallels. Filter df x, for filter either subset or df which and drop is equal to false. Mutate, here for example, if we want to create a new variable z is equal to x plus y with this data frame, here we have to write df z is equal to df x plus df y, or we have to make use of the transform function. I have already discussed transform function in the week of linear regression analysis. Pull df1, df1, pull df(x). So here pull df(x), but here it is df$x. Rename df(y) is equal to x. Here names df and then we have to write in the bracket df names df is equal to x is equal to y. So this is a very short name, rename. Here it works like this in base. Relocate dfy, d unique name df. Select dfxy, dfcxy, comma or subset. Select df starts with, here df, grep, then we are using this operator x and names df. Similarly, summarize df mean here mean df aggregate by slice. Say for example, if we have empty cars, first we are as underscore tibble empty cars because it is data frame, empty cars is data frame and iris is also a data frame. So we are going to use iris as tibble. Empty cars I have already talked, but iris data help iris. It is a very important data which is often used in multivariate analysis. See, it is in datasets package, Edgar Anderson's iris data description. This famous Fisher-Anderson's iris data set gives the measurement in centimeter of the various sepal length and sepal width, petal length and petal width for the 50 flowers from each of the 3 species of iris. The species are iris setosa and iris versicolor. So, now I will go to dplyr. So, we have converted these two objects into iris we have converted into as tibble and this one is tibble. So, arrange rows by variable. So, here arrange empty cars. See, empty cars we are using the pipe, empty cars, then arranging them cylinder and displacement. So, here cylinder and displacement we are arranging them. It is in increasing order. Then the DESC allows you to order selected variable in the decreasing order. So, what we have to do? Empty cars, arrange and then decreasing order, then that is also decreasing order. So, it gives in terms of decreasing order. This is the maximum number of cylinder and this is the maximum displacement. So, this way it is being arranged in decreasing order. This is DESC. Empty cars we can replicate with base R. This is the command with base R. So, I am not going to give the base commands R. Distinct, select distinct unique rows. So, df is equal to t sibbill, df is equal to t sibbill see, now we are going to use distinct elements of data frame, distinct x values, distinct x values. So, this gives distinct x values. These are the distinct x values. Keep all is equal to true. df distinct x keep dot all is equal to true. See, keep dot all is equal to true. So that means here keep dot all is equal to true means it is keeping all the values, all the variables, x and y both. And then unique data frame x, and it is unique data frame, and this one is duplicate drop is equal to false. This is the base parallel base command. Filter return the rows with matching. So here species is equal to human, is Star Wars see Star Wars. This is the data object with dplyr. We are filtering species is equal to human. So these are the human species have been selected. Star Wars filter mean mass greater than or equal to 100,000. So it will Star Wars, from Star Wars it will filter those rows whose mass is greater than 1000. So it is selecting those. So now I think I should stop here. So this way you can take help of the vignette. Many vignettes are available, and vignettes are the backbone to learn. They provide foundation to learn any package. So now I am going to stop this and I am going to talk about the next video in the next week, and that is 11th week, that is about time series analysis. So this is all about 10 weeks. Now I will go into the lectures 11th week, and that is about time series. So there is a gap. In my next lecture I am going to talk about time series analysis with R.